So next we're going to look at formula 4, which is the compound angle formula. And in this formula we're going to need a unit circle. So we're going to have to draw out a vertical and a horizontal axis. So we're going to have a unit circle which has a centre at 0, 0 and a radius of 1. So the radius of this circle is 1 because the radius of the unit circle is always 1. So in this unit circle we're going to draw 2 points. So the first point is going to be in the first quadrant and another point in the second quadrant. So we're going to call this point P and this point Q. So we're going to say this angle is B and this angle from here to here is A. So therefore this angle in between is A minus B. So in the unit circle, the coordinates of a point on the unit circle are equal to cos of the angle from here, from the say start point at 0 degrees. So cos of this angle B, and the y coordinate is sin of this angle B. That is because in the unit circle, if we were to form a right angle triangle, this adjacent here is equal to the x coordinate, and we know that if we were to get the cos of this angle B, it would be the adjacent over the hypotenuse, and in the unit circle the hypotenuse is here the radius, so we know that that's 1 in the unit circle. So cos of the angle is equal to the adjacent, and the adjacent is the x coordinate. So similarly for the opposite is equal to the y coordinate. And then in this for this triangle, for point P here, it's going to be, because this angle A, it's going to be cos A sin A. So then what we're going to do is we're going to join point P to point Q, and we're going to get the distance from P to Q in two different ways. So the first way that we're going to get the distance from P to Q is using the distance formula from coordinate geometry. So the distance formula is found in our log tables. So this is the formula that I'm going to use. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared, and that's the distance between 2 points. So I'm getting the distance between this point P and Q, so we'll call this x1 y1 and this x2 y2. So then if we're to put that into our formula, so it'll be x2, which is cos A, and then minus x1, which is cos B squared, and then y2 sin A minus sin B, which is y1 squared, and that's equal to PQ, which is the distance between P and Q. So, and now what I'm going to do is to get rid of my square root, I'm going to square both sides of this equation. So when I square both sides, I'm going to get rid of my square root, because if we square a square root, it cancels, because a square root is the same as something to the power of a half, and here we have a power raised to a power, so it's x to the power of 1. So now we don't have our square root. Sin A minus sin B squared. And now we're going to multiply this out. So when we do that, we get, so PQ squared is equal to, so it'll be cos squared A, and that's because cos of A all to be squared is equal, we can write that as cos squared A. So minus 2 cos A cos B, and then plus cos squared B, and then that's plus sin squared A minus 2 sin A sin B plus sin squared B. So now we're going to try and tidy this up a little bit. So we remember from our first trigonometric identity proof that if we have cos squared of an angle plus sin squared of that same angle, the answer it equals to 1. So if we were to group those together, so we have cos squared A and sin squared A. So if we were to put them alongside each other, and we also have cos squared B and sin squared B. So we put them beside each other. And we can put the other two at the end. So minus 2 cos A cos B minus 2 sin A sin B. So now if we're to tidy this up again, so cos squared A and sin squared A, well, that's going to equal to 1. Cos squared B plus sin squared B is also going to equal to 1. And then we put minus 2 cos A cos B minus 2 sin A sin B. So now we have PQ squared in a given format. So now what we're going to do is we're going to get the distance in another way. So we have to remember, so we use the coordinate geometry formula, but we can also treat this as a triangle and get the distance by means of the cosine rule. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos of a. So the cosine rule is also in our log tables. So this is the cosine rule here. So whatever side we're going to have as a, we have to put the angle opposite A as the angle that we're going to use in our formula. So for the cosine rule, I'm going to use this, so the triangle outlined in green, as my triangle. So PQ, this is my length here. So, and my angle in my triangle is A minus B. So if I'm to draw out that triangle, I'm going to have A minus B, PQ, and these sides are equal to 1 because the radius of the triangle is equal to 1. So this is my triangle here. So I'm going to let angle A, instead of angle A, I'm going to have angle A minus B. So the side that's going to have to go here is PQ, the side opposite that angle. So PQ squared is equal to, so B and C are going to be equal to 1. 1 squared plus 1 squared minus 2, 1, 1 cos A minus B. That's going to be PQ squared is equal to 1 plus 1 minus 2 cos A minus B. So then if I'm to, so now I have my formula in, so now I found the distance between P and Q using the cosine rule, but I also have the distance between P and Q using the distance formula. So this was using the distance formula and this was using the cosine rule. So now I'm going to equate these two formulas and let PQ squared equal PQ squared. So I'm going to let this equal to this. So let 1 plus 1 minus 2 cos A cos B minus 2 sin A sin B. So that's what I got from my distance formula. And let that equal to this here is equal to 1 plus 1 minus 2 cos A minus B. So now I'm going to try and rearrange and simplify this. So we have 1 and 1, so 2 on this side and 2 on that side. So it's going to cancel, and then I'm left with 2 cos A cos B minus 2 sin A sin B is equal to minus 2 cos A minus B. So now I'm going to take out minus 2 as a factor on each side. So minus 2 cos A cos B plus sin A sin B is equal to minus 2 cos A minus B. So if I divide both sides by minus 2, I'll get cos A cos B plus sin A sin B is equal to cos A minus B. And this is the compound angle formula that I wanted to prove at the start. So I can say that I have proven this trigonometric identity.